Now, in your notes, you have 4 equations on one page. 1, 2, 3, 4. And so I'm going to still do these 4 problems, but I'm going to do this problem by itself on its own page with a little bit of extra graphics to help me visualize what's happening. So here's question 1. Now, we need context here. Because a normal sine wave, the domain is infinity. So with this equation, if I just take this equation all by itself and don't have any context, the domain of sine is negative infinity to positive infinity. And how many answers is that going to have? Okay, sine theta equals 2/5. Well, 2/5 is 1, 2, 3, 4. 2/5 is 0.4. So on my graph, here's 0.5, 1/2. So 0.4 is just a little below this. So here is the line, y equals 2/5. So how many times does sine equal 2/5? Well, on this picture, 1, 2, 3, 4 answers. But really, this has infinite answers. So technically, this equation has infinite solutions. Do you guys understand what I'm saying? Because if sine graphs forever, then this is going to cross infinite times. You with me?
Yes.
Okay, good. So thanks for your answering for everybody. I think I appreciate that. Now, so we have a couple scenarios that we're going to run into. Sometimes I'm going to give you an equation and I want all infinite answers. But sometimes I only want the answers, and I'll qualify it. I may say solve on 0 to 2 pi. Okay, now if I limit the domain to 0 to 2 pi, so I go from 0 to 2 pi, how many answers will there be? Only this one and that one. Those are the only 2 times it crosses if I keep my window from 0 to 2 pi. I only have 2 solutions. And so it turns out if you can find the 2 solutions on one cycle, then you can find the infinite solutions. So let's concentrate on one cycle, 0 to 2 pi. Another way to think about this is the circle. If I go around the circle, how many times is sine positive? Well, sine is positive in a smart trig class. So I have a positive answer over in quadrant 1, and this is positive, so I've got my 2/5, it's a positive number, and sine is positive in quadrant 2. So I have 2 answers that I'm hunting down here. I need quadrant 1. Theta is in quadrant 1, and theta is in quadrant 2. I need 2 answers here. I need this one. This is like the quadrant 1 part, and this is like the quadrant 2 part. Now, here's the dilemma. We can use sine inverse. theta will equal sine inverse of positive 2/5. Now here's my dilemma. As soon as I switch to sine inverse, I have to rely on the restrictions, and the restrictions are only here. I'm restricted to which quadrants. When I answer this one, which quadrants will theta possibly come out as?
1 and 3, but not 2.
You're really close.
Quadrant 1.
1 and 4. Over here is quadrant 4. So, but you were, I think that was Jonathan at first. He said 1 and 3.
Right, I see.
That was close. I mean, you have the right idea. When the ratio is positive, theta will come out as a quadrant 1. When the ratio is negative, theta will come out as quadrant 4. So since I have a positive angle, I'm going to get a quadrant 1 answer. Okay, let's do it in degrees. And let's pull up our calculator and get a degree answer here. And so we're going to make sure we're in degree mode. We are. And then we're going to do sine inverse of 2 divided by 5. And we get 23.5 degrees. Let's call it 23.6 degrees. So theta is 23.6 degrees. And that's in which quadrant?
First one.
Quadrant 1. So when I look at my picture, this is like 23 degrees over. You know, if this is 0, this is 90, that's 180. So here's 90. 23 is way close to the 0, so there's where 23 would be landing. So that's where my first intersection is, my first solution. But my second intersection, my next solution is in quadrant 2 over here. So I have an answer right here, 23.6 degrees. But I have another answer over here. Now the other answer has the same reference angle, 23.6 degrees. So what is this other solution going to be in quadrant 2? How do I find a quadrant 2 answer if I know the reference angle?
Subtract from 180.
Exactly. Theta is going to equal 180 minus the reference angle. Now, because 23 is less than 90, this first answer is the answer in quadrant 1, but it is also the number I can use from my reference angle. So I can take 180 minus 23.6, and now I'm going to get theta for my other solution. So we have 180 minus, I'm just going to go up and grab that number, and I got 156.4. So this equation has two answers. The first one is in quadrant 1, and this second one is in quadrant 2. Now notice when I did the inverse trig function, it only gave me quadrant 1. It did not give me quadrant 2. We had to figure out quadrant 2 by using the reference angle ideas. Sine inverse will never answer quadrant 2 or quadrant 3. Let me pause with that. Any questions? Okay, so really, it's very simple. You use the inverse trig function to find quadrant 1, use quadrant 1 as the reference angle, and then you can use the reference angle to find quadrant 2 or 3 or 4, whichever other one you need. So you get the inverse trig function to get your reference angle, and then use the reference angle to find any other solution that might exist. Okay, let's do the second equation here. Okay, so this time we're going to solve a sine graph. I'm sorry, a cosine graph. Okay, so cosine had a different restriction. Remember, cosine was restricted from 0 to pi. Now, ultimately, I don't think that visualizing with the cosine graph is the best strategy, but I wanted to help you start visualizing what's happening here. Cosine equals negative 5 pi sixths. This has infinite answers, but because if we look at negative 5 pi sixths, that's about, well, it is 0.83, negative 0.83. So here's negative 1. So negative 0.83 is like that. And I'm going to have infinite solutions because the 0.83 or 5/6 is negative 5/6 is going to cross cosine many times. 4 on this picture. But because the wave keeps going forever, it's going to cross infinite times. So for simplicity on our first go around here, we're going to solve on x or on theta, where theta is in between 0 and 360 degrees. Now, the picture is in terms of pi, but let's do degrees first until we get more comfortable or more used to this. Okay, now we can visualize on 0 to 360, then we're only looking at that. And how many solutions are there from 0 to 2 pi or 0 to 360? There's only 2 answers. But the inverse cosine can only find one of them. It only finds between 0 and pi. It finds none of these and none of those. So we got a little bit of a dilemma to deal with here. Another dilemma to deal with too is the negative. The negative doesn't work consistently for putting us in the right quadrant. It does okay on cosine, but not sine inverse. So I'm going to show you a trick here. The trick is everything on sine, cosine, and tangent has quadrant 1 in common. So sine inverse, cosine inverse, tangent inverse always give you reliably quadrant 1 answer. But for it to be in quadrant 1, it has to be positive. All right, so we're going to use a trick here. They're all positive in quadrant 1. And when we find quadrant 1, we have the reference angle. So here's the trick. This takes a little bit of getting used to, but I want to find theta. So I'm going to get theta by itself. I'm going to do the inverse on both sides. So I'm going to take theta equals to the cosine inverse of, now leave that blank for a moment. Cosine inverse will give me a positive if I'm in quadrant 1, and cosine is negative. A smart trig class. So cosine is positive in 1 and 2, but cosine will be negative over here in quadrant 2. And so that's it. Cosine inverse can only give positive ratios in quadrant 1 and negative ratios in quadrant 2. And if I negative here, I'm going to get quadrant 2 answer, but I want the reference angle. So here's the trick I'm going to play on the problem. Always use positive ratios. Force it to be positive. We're going to force it to be positive. And then I'm going to put in the 5/6. Now, if I force it to be positive, the theta I'm going to get is quadrant 1. It's going to tell me the reference angle. And now we can use the calculator. And the calculator is going to give me quadrant 1. And that's really the technique that works all the time for sine inverse, cosine inverse, tan inverse, is to always get the reference angle. So I do cosine inverse of 5 divided by 6, and I get 33.55 degrees. Let's call that 33.6 degrees. All right, so just put in a positive number, you got the reference angle. Now let's go back and answer the question. The question is bigger than the reference angle because we're supposed to have it equal negative. Now, when is cosine negative? Can you guys tell me which quadrants will theta need to be in so cosine comes out with a negative answer?
2 or 3.
Correct. So, because we're doing a smart trig class, cosine is positive in 1 and 4, but cosine will be negative in 2 and 3. And so this theta, whatever it is, to be negative means that theta could be in quadrant 2 or quadrant 3 answers. Now, the inverse trig functions don't reliably give us all the quadrants. They're restricted. The only one that all the trig functions reliably give us all the time is quadrant 1. And that's our reference. And so all the trig functions are very reliably going to give you the reference angle every time. So if you always force it to be positive, you will reliably always get the correct reference angle, whether it's sine inverse, cosine inverse, or tan inverse. But if you know the reference angle, can you tell me the quadrant 2 answer? This is the true answer now. That's the reference angle. How do I get the quadrant 2 answer that's over here?
180 minus 33.6.
Exactly. So 180 minus, go up and grab that, around that, let's call that 146.4 degrees. So I got the quadrant 2 answer. But I also have another time where negative is, cosine is negative, and that's in quadrant 3. Now I need a quadrant 3 answer. So this will be my true solution. The first one was just the reference angle solution. I'm using the reference angle solution to find these real solutions. So theta will equal, if we're in quadrant 3, how do we get that? Well, we went 180 plus the reference angle. So it's 180 plus the reference angle, 180 plus the 33.6. And that's going to be, these are approximates now. 213.6 degrees. second solution. All right, this takes practice, but it all comes down to finding the reference angle. Now, the first one was a little bit easier because it was positive. And since I started out positive, I got a positive input, I got the reference angle, and that's what I needed because one of the answers was in quadrant 1. So I didn't have to worry about forcing it to be positive because it was already positive and I already got the reference angle, the quadrant 1 solution. And then I used the reference angle to find the quadrant 2 solution. Same strategy over here, except both angles were the ratio was negative, which forced the answers in different quadrants than 1. So I found quadrant 1, used that as the reference angle to come up with quadrant 2 and quadrant 3 solutions.